Okay. Hi, everyone, and welcome to this session today. We're hosting the session on the Gifted World platform. I'd just like to take a few minutes to tell you about the platform, introduce myself, and then introduce our speaker for today. Thank you all for taking the time to come out here on a Saturday afternoon or evening. And we really hope that you enjoy and learn a lot from today's session. To tell you a little bit about Gifted, we are an online platform that started earlier this year. Our goal is to provide a nurturing community that enables students, teachers, and parents to reach their full potential in learning and enjoying life. Uh, we've been started by 3 different partners: Educational Initiatives, EI, that runs the asset exams; GenWise, which runs gifted summer programs for many years; and the Center for Talent Development at Northwestern University. Today's session by Vishnu Agnihotri is on how to become a conceptual learner. Like this, we have many sessions that happen every month. As you've all joined our community, joined our email list, you'll get notified of this. We also, in case you enjoyed today's session, have a series of sessions coming up in January called Connecting the Dots. They're designed by our exceptional mentor community, and the goal is to provide challenging learning resources and environment and assignments for you to connect the dots between the often disjointed subject-wise learning that tends to happen in school. So it's split into a senior track and a junior track. The senior track is for grades 6 to 8, and the junior track is for grades 4 and 5. In the senior track, it's there in physics, generative AI, mathematics, and in the junior track, it's there in science and in math. Okay, you can see all the details on our website by just going to online courses. And we also have an exciting upcoming masterclass that's happening just next week on the science of speed, being taken by Karthik Raghavan. Without further ado, I'd like to introduce you to our speaker for today, or the mentor for today, Vishnu Agnihotri. Vishnu is one of the founding members of GenWise and therefore of Gifted World. And he's been in the space of gifted and talented education for over a decade now. Vishnu is a person who when I initially met Vishnu, I knew him as this person who knows a lot of interesting educators. And that is so true. Anyone in education who sort of thinks deeply and teaches very well in India, they know Vishnu, or Vishnu knows them. Or with 1 degree of separation, they will know Vishnu. So he has really, over the years, created an incredible network of educators who are really, really passionate about teaching and teaching well. So with that, today's session is how to be a conceptual learner, and I turn it over to Vishnu. Just a reminder, you will not be able to unmute yourself during most of the session, okay? Just because we're a large group of people. But there are polls to interact with, and if you have a question, just raise your hand or put your question in the chat. We will make sure to get to as many of them as we can over the course of this session. With that, over to Vishnu.
Thank you very much, Siddharth. So I'm glad that there are close to 50 people on a Saturday afternoon, evening, most of them children, some of them teachers attending this. So which means there's a lot of enthusiasm for learning. I think many of you might have attempted some of the quiz questions, the Think Deeper challenge, which was sent out. I have been through your very interesting responses. I will cover some of those responses. So I'm going to jump very quickly into my presentation. But before that, I just want to show you one thing. One of the questions in the quiz was that if there is ice put into a glass of water, and therefore the level of water is, at a certain level, after the ice melts, what will happen to the level of water? Will it rise? Will it remain the same? Will it go down? So based on the answers, I think almost none of you tried this experiment. Right? So it's a tricky one to understand and explain. I myself have been confused about it several times. So I thought we will do this experiment, and I'm going to show it to you now because these ice cubes might melt pretty soon. So what I've done, I don't know whether you need to spotlight me or it's pretty clear. So yeah, wait. Oh,
You'll have
because
to
of this
switch off the
virtual
virtual background
background, maybe,
right in front of your shirt.
okay, I'll have to put it in front of my shirt. Okay, so I put a bunch of eyes, and that highest black mark which you see, so I put it on a table and I used a permanent marker. So that is, oh, okay. But do I have the original level? Okay. So this experiment may be a little bit messed up, but we will see what happens, right? Okay. So because I had done it even before this and I realized the ice was melting very soon. So let's see. And you can do this experiment after today's session and tell me what happens. So I'm going to share my screen and get into the thing. Yeah. Okay. Right. So I know that there are three types of people here, mostly children and students. This was meant to be a session for students in grade 7 and above, but I noticed that there are grade 4, 5, and 6 children also, which is fine. Many of these things you can understand. Some of these things may be a little bit higher level, but that's fine. That's not an issue. I also know that there are some teachers from Dubai and India, and there are some parents also. It's all good. Many of the parents have answered some questions wrongly. Many of the fifth standard kids have answered it correctly. So it's all, pretty much even when it comes to this. There are, of course, some things adults find much easier. I'll talk about that also. So so there can be two alternate titles to this session. So how to become a conceptual learner, or how to think more deeply, or how to think from first principles. And I'll talk about what is thinking from first principles. So I'll talk for about 4 or 5 minutes about what is conceptual learning, why do we need to engage in that. But then the bulk of the session, for about 40 minutes, 45 minutes, we will get into some questions, your responses. We'll have some polls and things like that. We'll also spend some time on a couple of small experiments. And then towards the end, last 15 minutes, I'll try to put it all together and give you some tips on how to become a conceptual learner. It's basically like doing exercise and building your body, right? It's not, you become a deep thinker, you learn to think very well, basically by exercising those muscles. And sometimes just doing the schoolwork is not enough for that, right? So that's what the session is about. So let's get into it. Okay. Why is the next slide not coming on? Okay. I think Siddharth has already introduced gifted words, so I'm not going to get into that. So what is conceptual learning? Why should we aim for it? So I'll keep it simple. So this is a quote from Elon Musk. So what he's saying here is that the chef is a trailblazer. Trailblazer means doing new things, right? Yeah, so Akshan was going to tell us what a trailblazer is, but that's fine. I mean, we are a little bit short of time, so it may not be as interactive as I would like it to be. So the chef is a trailblazer, somebody who invents recipes, right? The new kind of pizza, or new kind of golgappa, or whatever thing. So he knows the raw ingredients, how to combine them. The cook reasons somewhat differently, uses a recipe and follows that recipe. Cooks are important. We are not running down cooks here. But if the cook lost the recipe, he would not know how to cook the dish. Or he may remember it, but he may not be able to do something new with it. The chef has a deeper understanding and can do a lot more, right? So let me give you an example from the cooking thing itself. This is something I did not know some years ago. We had a we know a very good food scientist. He's a so he was doing a session for the students on cooking. So one of the things was making shrikhand, right? So using saffron and shrikhand. Um, so he told us that we should soak it in milk for some time, right? In some other session where we were making cinnamon tea, cinnamon is basically dalchini. He had told us to soak it in milk there also, right? Now we could blindly follow this and do that, and definitely soaked in milk, the cinnamon tea tastes much better. Soaked in milk, the saffron when it is used in the shrikhand comes out much better. But why is that happening? So he told us the chemistry part of it. We did not know it. So there are oil soluble essences, and there are um, sort of water soluble things. So milk has various fats and oils in it, and therefore the flavor comes out much better in milk. So this is an example. A chef would know such things, right? Therefore, a chef would be able to do a much better thing. Chef is just an analogy we are using, right? Now, you might want to be a mathematician, you might want to be a dancer, you might want to be an engineer, you might want to be a lawyer, you might want to be a writer. Uh, but if you aspire to be a trailblazer, a really expert person in that field, you need to develop conceptual understanding. It's not enough to be at the surface. So if you want to be a really good writer, you have to know how words and sentences work, how great writers, create suspense and emotion, or how great musicians create tension and then, resolve it, or how great mathematicians make certain assumptions, build mathematical systems. So that is what this session is about. Of course, we have to crawl and walk before we can fly. So the next few years, you have to, develop all these conceptual understanding muscles before you can do these trailblazing things. And I'm sure many of you will do these things. So why should we aim for it? Yes, because we want to be trailblazers. Not just that, there are other reasons. So disconnected learning makes things more difficult than they are. So for example, maybe we got confused. Maybe we think fractions is different from ratios, is different from percentages, but they're all, almost the same thing. And if you understand that, we have to remember far less. Learning becomes easy. Otherwise, we're mugging up, trying to remember some arbitrary rules. And we might be doing well in school. We might think we are doing well. We've understood these things. But learning may be very fragile. So when it is disconnected, when you don't understand all these connections, it's much harder to remember. It's very sort of shaky. It's like a house of cards. It can just collapse. And finally, what I've been saying is that when you aim for conceptual understanding, it's still a phrase. By the end of this session, you will know what conceptual understanding means through the examples, through the questions we discuss. So it builds the capability to think from first principles. And I'm going to come very soon to what does it mean to think from first principles. So the journey to conceptual understanding is long. You have to do more work. It takes more time. But taking the shortcut, oh, this is the formula, I'll use this, I'll do this, it creates serious problems in the long run. So you know those shortcuts, you do well, maybe you crack your board exams, but then you go into research, you go to a very good college, you go to work, and suddenly you find that you actually don't understand that. And it's happened to me, right? I'm from a pretty good college, but at the age of 35, 36, when I was setting asset papers and checking them, there were questions of grade 6 which I did not understand. I mean, I would have answered and done well, but I actually did not understand that idea, right? So it takes time. There are many layers to it, but it's worthwhile. I think Elon Musk is very popular among many children of your age. So I'm going to use another Elon Musk quote here. And many of you know that Elon Musk revolutionized the entire rocket industry with SpaceX. And people used to spend tens of millions of dollars on rockets, and so Musk actually revolutionized the whole thing, right? So what he says is, I tend to approach things from a physics framework. Physics teaches you to reason from first principles rather than by analogy. I won't get into the technicalities of analogy versus physics, but basically he was asking a lot of why questions. What is this? Why is this? So what is a rocket made of? Okay, aerospace grade aluminium alloys, titanium, copper, carbon fiber. Then he went to the commodity market. What is the value of these materials? So just the materials alone was just 2% of the price of a rocket, right? So 98% is the cost of design, maybe a little bit of manufacturing, whatever. So that told him that some make his own rockets, bring down the price of rockets, and do a lot of other things. Siddharth, can you hear me? There is some, okay, internet
Yes.
connection was unstable. Okay, fine. I will also keep my mobile hotspot in case things go wrong. Okay. Right. So first principles is to really, think from scratch, and we will be doing some of that in this session. Okay, so let's get into these questions. I think many of you have, and we can engage with that. So some of you may be from Bangalore. If you're not from Bangalore, you're still from a large city and you know traffic congestion, and all of you have been stuck in jams, I'm sure. So here the question is that there is a busy Whitefield area in Bangalore, and there's a conflict over a dedicated bus lane. It's not yet there. Uh, Somebody has proposed that there'll be a dedicated bus lane on the main 100 feet road. The road is 100 feet wide. And basically, dedicated bus lane means only buses can go in that lane. Cars, two-wheelers, and other vehicles cannot go. And there are some people favoring that. The Residents Public Transport Association, they are saying that it will reduce the travel time for thousands of people who travel by bus, and therefore, they are in favor of it. The people who drive cars and two-wheelers, the private vehicle owners group, opposes this. They say that the space for cars will reduce, traffic congestion will go up, and it will affect families. So children may be going to school by car, or people may be going to office by car, right? So there is some arguments over this, and in the media, there are various statements media is making. So I'm going to show 3 of those statements. There were 5 statements in that actual quiz, and we will do a poll where you will have to say whether it was unbiased, whether it was the statement was favoring the bus corridor group or the private vehicle group. So I'm going to launch a poll in Zoom and do this. How do I see the Zoom poll? Yeah, okay. Controls, more polls. Yeah. So I'll just give you a couple of minutes. It shouldn't take long. So we can start answering these questions. So answer 3 questions. There are 3 questions in the poll. Answer all of them. Yeah, about half of you have responded. I'll give it another minute and okay, I'm planning to end the poll now unless any of you still want to respond. Okay, I'll give it a few more seconds. People are still responding. Yeah. Okay, I'll end because almost everyone has responded. So I think we should be good. Apologies if you're still responding. Okay, I'm going to end the poll and share the results. Okay, so let's look at what people have said. So the first statement, car owners face fresh assault. Uh, yeah, as authorities snatch away another lane from already congested roads. So yes, the correct answer is that the private vehicle owners group is favored here, and 51% have answered correctly. I also see that there are quite a few students who are here who are very young, who are in grade 5 and grade 4. So this can be tricky for very young children. So I will disregard, that kind of a thing. As per my analysis, generally 70% of people have answered this correctly. For an adult, it's a much easier question. Um, so progressive transport initiative blocked by luxury car lobby despite rising pollution levels. Right, the correct answer is that the dedicated bus corridor group is favored here because they are saying it's progressive, it's blocked by luxury car lobby and so on. We will go into a bit of detail about how to analyze these statements. But again, roughly 50% have answered correctly. And, yeah. Again, the third one, majority of road users who rely on public transport continue to suffer as a small group of car owners resist change. Here, almost 60% have answered it correctly that it favors the dedicated bus corridor group. Yeah, okay, so that's useful. So what we see is that it's not completely trivial for a young student, right? Maybe for adults, this is almost a trivial kind of question, but it's not completely trivial. So let's look at the reasons people gave for their answers. I'm going to share some, and some of you, I think maybe did not do the poll. You said you already answered it in the Google form which was shared. I've analyzed that data also. So yeah, the poll and what comes out here is similar. In the Google form, there is a slightly better performance, probably because people had more time, or maybe there are more younger children out here. But what I want to spend time on is the responses, how it has been analyzed, right? So this is, I'm taking two examples. There were a lot of good responses from students as well as adults. So Shreyansh from of grade 6 from Rajkot, the Galaxy School, Wadi, he analyzed statement 1E. Statement 1E was that essential private vehicles will be forced to squeeze into remaining lanes while empty buses enjoy dedicated space. So he nicely caught on to these adjectives. Essential private vehicles, right? Private vehicles is neutral, but are they essential? That is something we can critique, right? Forced to squeeze, forced, squeeze, right? And empty buses. Are buses really empty? Are they enjoying dedicated space? So he's very nicely caught on to these things. And I love the way he's answered this, right? They create an image of hardship and necessity for car users, while empty buses enjoy dedicated space exaggerates the idea that buses are unused and wasteful, right? So this exaggeration favors private vehicles by downplaying the efficiency or need for bus lanes. Similarly, Chitrakshi Baral, grade 8, the Newtown School, Newtown, Kolkata. I don't know if you are here, out here. If you're out here, just send a chat to let Siddharth know that you're here. So he's made some very nice observations that emotionally charged words have been used, uh, like snatched, suffer, backseat, forced to squeeze, right? And car owners have been presented as being acted upon by authorities. Car owners were labeled as small group, luxury car owners by the other side, right? So this is quite interesting. So the way we learn conceptually will differ across different fields. The way we learn conceptually in maths may differ from the way we learn conceptually in the social sciences, right? So in language or the social sciences, we may have to ask, is this language neutral? Who wrote this? Do they have a vested interest? Which group do they belong to? Uh, Even in science, this may be necessary. So the boundaries are not that this thing. But sometimes in science, there's really hard data and clear thing. But yes, so these are things to keep in mind. Uh, and if some of you parents and teachers are in the group, please look up a book called The Unschooled Mind by Howard Gardner. It's an excellent book. And he talks about how conceptual understanding in these three fields are different, how in science misconceptions are a big challenge, how in social sciences stereotypes are a big challenge. So if you're a teacher or a parent, you may want to look up that book. Yeah. So, okay. You will understand why I'm presenting this table pretty soon. Maybe not immediately, but in the next 10-15 minutes. So last evening, I extracted the data of all the people who had responded to the Google form. 41 people had attempted the entire quiz by that time. All those 41 people responded to this question. 25 answered correctly, which means about 61% answered correctly and 100% attempted this. And as we go along to the other questions, we will see what happened. Yeah. Okay. Okay. Yeah. This is a somewhat tricky question, especially for students below grade 6, 7 level, I think, and even for engineers, I think it is not easy, though it should not be so difficult. So, a floating pontoon, like a floating jetty, um, it's used for travelers in the boat to get off the boat, walk on it, come to the steps on land. Uh, what materials can be used to make a floating pontoon? So there were 5 choices, and you could choose more than one: steel, aluminium, plastic, wood, concrete. Um, yeah. I think I also asked in one of these sub questions is, can you do an experiment to sort of justify your answer and so on? Nobody, I mean, people said that they can do this and that experiment, but nobody actually did an experiment and shared, which is okay. But I'll show you an experiment now. So let's see, let's have a poll on this and then we will look at the results also. So it's poll time again, and let me find my Zoom controls.
No, I can just launch the poll if
You
that
can
helps.
launch the poll. Okay, thank you so much. Yeah. So it's just this floating pontoon question, unlike the previous one, which had 3. Just, I've put in a slightly different form, so just read it carefully.
We're at 80% participation, so I think we can.
Yeah, should I end the poll then, or you can end the poll? Yeah, go ahead and end the poll. Don't share the results yet.
Yeah, not sharing.
Okay, so we'll share the results soon, but let's do a small experiment. This is the more fun part. Otherwise, we're not doing so many experiments out here. So should I stop the sharing? Yeah, because I want to show something. So, okay. So I have this, okay, I'll put it against my shirt, otherwise it's a problem. This is the problem with these virtual backgrounds. Okay, so I have this jar of water and I have this aluminum foil, like the one you have at home to maybe wrap food and stuff like that. Aluminum is a metal. Now, this is very, very thinly rolled. It's extremely light. I don't even think it's half a gram. So I'm going to crumple this, right? I've not pressed it much and all that. Okay, I've just crumpled it lightly. Now, what do you think will happen when I put it in this jar? You can just respond on chat. And Siddharth, you can tell me, will it float? Will it sink? What will happen? This is a metal. All of you know it's a metal. Okay. So some people are saying float and
We're
many people are
getting more
saying fall.
votes for float
More
and
floats?
only one for sink.
Only one for sink. Okay, okay, okay. Interesting. Okay. So a lot of floats. I'm wondering why they are saying float. Okay, but let's see. Okay, the float party is correct. But would someone like to unmute themselves and say why it is floating?
Uh,
Yeah, say more than density. Okay, Akshan, go ahead.
Sir, because the water is more denser than the aluminium foil, sir, that's why the aluminium is floating on the surface.
Okay. Okay. I'm not saying whether you're right or wrong. We will figure it out. Okay. Akshan, can you check the table in the... Okay. What is the density of aluminium? Is aluminium really less dense than water?
Sir,
Madhura is disagreeing. Madhura, would you like to say something?
Yeah.
Yeah.
Though aluminum in the table is actually more denser than water, I think the surface area of the boat over the water made it float.
Okay. Okay. Ishan is saying average density is less. Ishan, tell us what you mean by average density.
So average density is like the density of the whole body. Since you crumbled it lightly, there are gaps in between the aluminum foil, which makes the density decrease. Therefore, the density of the body is less than the density of water.
Okay, that's very interesting, Ishan. So I'm
sir,
going to...
I want to counter Madhura's. She said that if it covers more surface area, then it will float. But sir, in that glass of water as well, sir, if you put like a tiny piece of aluminium as well, it will still float.
Okay.
Sir, so it doesn't matter the surface area.
Okay. Thanks, Akshan. That's a good point. So I like Ishan's point. Did you hear what Ishan said? Ishan is saying that I crumpled it lightly. There is air in it. So we must take the average density of air and aluminium to figure this out. So what I'm going to do is, I don't know if you've helped your mothers and fathers to make chutney or, do something in the kitchen, but what am I doing? I took this aluminum foil and I'm really banging on it. Okay. So I'm trying to drive out all the air from this thing. So let us see if I succeed in that. So I've got this thing with me. I'm going to crumple it further and like hit it even more. Yeah, because it gives me a lot of joy to sort of, stamp this thing. Okay. Okay.
For all of you when you're frustrated.
Okay. So now it's the same aluminum foil. Ishan was saying that there was air in it. So I've really, made it like into a potato chip kind of a thing. So what will happen now?
Float.
Okay, it's completely sunk to the bottom. Right. So Ishan is correct. And unfortunately, I think a lot of textbooks and in the classrooms it doesn't get discussed. And I had to figure it out the hard way as to why ships, which weigh tons and made of steel float. Yeah. So do experiments. So that is one way to learn conceptually. The experiment itself may not teach you why it's happening, but it can, give you some clues and help you understand things. So I'm going to share my screen again and get back to the
Did you want
thing.
results?
Let's see the poll results, right? Yeah. Okay. So 47% said plastic and wood only because they seem to be lighter materials. Generally, we see them floating and so on. 19% said aluminium. And so only 13% actually got this right, and which is completely fine. This is a tricky question. I'm sure that a lot of engineers will not do better. So no worries with that. So I'm going to share my PPT again. So this is conceptual learning, right? It's possible to do all your physics sums and score 100 in your physics, with your D is equal to M by V and do all of that, but still not really understand something like this, right? So you have to keep asking questions. Okay. So you have to take the average density. The density of air is almost 1,000 times less than that of water, right? And these pontoons can be made of concrete also. They can put a foam core, foam maybe 25, 30, 100 kilogram per cubic meters. There are steel pontoons. Okay, I'm going to ask you one more question. I know we don't have much time, so I don't want to go
Sir,
too
I
deep
had a
into.
doubt.
Yeah, Akshan.
Sir, in the poll answer, it said that steel and concrete can also float.
Yes.
Sir, but how?
Yeah.
About the area or something?
No, this is what. See, okay, so let me explain, right? So when Ishan said you have to take the average density, so what you do is, so for example, right? This, you see this plastic jar, right? So basically, concrete may be much heavier, right? Steel may be much heavier. But if I have mostly air in it, for example, okay, how can I get a laser pointer kind of a thing? So, or I can use annotate, right?
Your mouse around on your screen, it will show for us.
Oh, does that? Okay. So is it showing my mouse now?
Yes,
Okay. Yeah. So Akshan, what you see is this is an empty compartment. This is basically air. So imagine this is steel, which is heavy, but most of the volume is air, right? So it's like a life jacket kind of a thing. How do you float the life jacket? So a lot of it is air. So the average density comes down. So which grade are you in, Akshan? Okay.
Sir, 7th grade.
7th grade, right. So try to, we can discuss this offline. You can send me an email. We can, chat about this. Basically, more of the space is occupied by air or foam, which is less dense. And there is very little concrete or steel to give it the strength. So that is how it manages to float. And you can do the arithmetic and mathematics to get it. Devik, I'm sorry, we will not be able to take that question right now. Please send it in chat or later if you have time. We'll look it up. So, okay. And there are different tools to understand this. For example, you can do an interactive. So, Akshan, you can actually play around with this. Devik, you can play around with this. So you go to the FET Colorado. We'll share this deck with you. You can look up all these things. So you can actually do a lot of virtual experiments. I would like you to do physical experiments, but maybe, it's hard to get a concrete thing with air filled in it and stuff like that. But you can do similar things. You can make it in the form of a boat. You can, uh, have it in the form of a bottle, and you can try different things. I can send you a write-up on what kind of experiment to perform. So, right. I'm not going to spend too much time on one concept or get too much into these things because I want to give you certain tips and tricks and how you can become a conceptual learner. If you come for the connecting the dots course or other things, or come to Gifted World master classes, slowly you will build up many of these things. So in the quiz on the Google form, the responses were similar. So very few actually got the correct answer, because it is a tricky question. So how many attempted? Almost everybody attempted, but only 5% got it correct in the Google form quiz. Poll time, ice in water. Unfortunately, I spoiled the experiment. I had it there and I forgot and I drank some of the water. So you can do this
Shall I run the
experiment.
poll?
Yeah.
Shall I run the poll?
Yeah, please run the poll. Yeah. So this experiment I can't show you, but I think we can end the poll, Siddharth. I think you can get a rough idea. And share the results also. Yeah. So 60% of you have said that the water level will rise. This is a tricky question. The correct answer is it remains the same. I'm not going to explain this here. But the reason I kept this question is I was hoping that you would at least do the experiment, because all of you have refrigerators at home. You can get ice, you can get water. So even whether you understand it or not, you could have tested it out for yourself. But most of you have answered without doing the experiment, which is fine. But please do this experiment and write to us. And we can, I mean, it's a little tricky to understand, but we can send you an explanation later about this. Yeah. So that is that on ice and water. I want to move on to some other questions. Yeah, there was a similar response in the Google form quiz. How many attempted this? This also a lot of people attempted. Almost everybody attempted. But only 27% got it correct. This 27% is of the people who attempted. If for people who are very nitpicky and particular about what exactly we did. Okay, this was a fun question where you had to ask questions, you didn't have to give an answer. So there were some facts about phytoplankton. I'm not going to read these facts. So various facts, and people were asked to ask questions about phytoplankton. I'm happy to say that we got a lot of excellent questions. People were very creative. Wonderful questions came. And I'll just share 2-3 questions which, I really liked. So for example, If they glow and create blue lights at night, how come the blooms are green or red? Somebody asked this question. Somebody asked, are phytoplankton the bridge organism between a plant and non-plant living organisms? If the nutrients required by phytoplanktons arrive in the water through dust from deserts, the huge sandstorms that blow on deserts like the Sahara can be considered life-giving for the planet. So there were a lot of interesting questions which came out, and I really appreciate these questions. I'm going to come back later to the importance of questions. So great job. Everyone asked great questions about what, how, why kind of questions. I want to share a bit about some of the questions I asked when I first saw this, because I'm not from a biology background. My background is more in engineering. So when I saw this thing that phytoplankton die and they sink, I'm wondering why the hell do they sink? And I did some Google search, and then I found that there is something called gas vesicles. So which are like sort of, bubble, empty kind of, bags kind of a thing. And apparently that what is holding it is like a protein membrane, a specialized protein membrane. But when they die, then they should still float. But then I started Googling more. It said gases enter through passive diffusion. All hi-fi words, but basically somehow diffusing across the membrane. Why doesn't water enter? Hydrophobic interior. On death, the protein membrane degrades. The reason I'm sharing, it's not that I want you to know about gas vesicles or passive diffusion or any of these things. What I want to tell you is that the more you understand, the more questions you will have, right? The more you understand, the more questions you will have, and there are levels of depth. So this concept of density and flotation for the next 20 years, you could be learning, right? You obviously have to get more clearer about it to some extent. So if you're a curious learner, you will really enjoy it. So do not think that there is an end answer, right? You understand it to a certain level, which is great, but then you can ask many more questions about it. For example, when I was doing this density thing 6-7 years ago, a student asked me, okay, buoyancy and this thing and, pushed up, if this density is less, it comes up. But why? Right? Honestly, I was, foxed. I said something at that point of time, and I think it's correct. So I thought that, densities, things are more packed, more tightly packed. Therefore, they can offer more resistance. But that's a very qualitative thing. You can actually derive this using pressure laws. So this is just to tell you that there is a lot of depth and layers, and the conceptual journey is long. It's not that, overnight you understand concepts and it's done. Yeah. How many attempted this? Because they only had to ask questions. I guess, everyone answered this. And of course, there is no wrong question here. This is an interesting one. Why do the divisibility rules for 2, 4, and 8 work? Would anyone who's clear about this, would they like to explain the answer? You can raise your hand if you're clear. Otherwise, I'll read out a student's. Okay. Okay, I'm going to go ahead in the interest of time. So this is a very beautiful answer from Tanjavur, Tamarai International School, Arfan Mohammed, R, grade 7. So all of us know these rules, or I didn't even know, honestly, I'd forgotten all these rules. But if I was in 6th standard, I think I would know the answer. So we write 624, 624, we do a lot of operations, but we actually forget that 624 is just one representation of the number 624 in the decimal system. So what is the decimal system? It is basically about 6 into 100 plus 2 into 10 plus 4 into 1, or 6 into 10 to the power 2 plus 2 into 10 to the power 1 plus 4 into 10 to the power 0. In a base 2, in binary, we might write it different. In hexadecimal, system with a base 16, we may write it different. So Arfan has given a very nice answer, right? So what he's caught on to, understood, and what he's explaining is that 624 is basically like what I explained, right? 6 into 100 plus 2 into 10 plus 4 into this thing. 100 is divisible by 4. We know that, right? 4 into 25 is 100. 10, is it divisible by 4? Is 10 divisible by 4? No, right? That is why we have to check the last two digits for divisibility by 4. For divisibility by 2, we could just check the last digit because 10 is divisible by 2. So you are multiplying the number in the tenths place by 10, hundreds place by 100. That gives you the assurance that it is divisible by. So if it is the hundreds place, you know that 600 is definitely divisible by 4. So we only have to bother about looking at the last two digits. Are they divisible by 4? So similarly for 8, you have to look at the last three digits because 1000 is divisible by 8. So beautiful answer, Arfan. I don't know if you're here. If you're here, just send a message to Siddharth. So knowing why is really, really helpful. So knowing these kind of things make your number sense much stronger. If you will understand numbers much better. You'll do better in math. If tomorrow you want to get into number theory or something, these are the building blocks, right? So sometimes students are misguided. They say that why should I know my multiplication tables, or why should I be able to do this mentally and so on. There are calculators, I can do it on the computer. But the thing is, there is something called working memory. In the brain, you can hold only so many pieces of information in your mind. So when all these things, you do a lot of practice, it becomes part of you, becomes part of your long-term memory. Then, you can be a real trailblazer. You really understand it deeply. You can do it well. So this was a tricky one. Very, very few people answered it correctly, and it's fine. I mean, even when we interact with teachers, we find that, immediately a lot of teachers don't get it. I myself did not understand this, and my colleague Soumya had to give me a hint for this. Okay. So, so you can see that only about half the people attempted this, right? So far we had most of the people attempting this, but here only about half the people attended this, and only 3 people actually answered correctly, including the boy, whose thing I shared, which is fine. It's fine to not know many of these things, but to ask these questions is important, right? At least in the subjects you love, you must ask these questions. And if you're a teacher, absolutely you need to know these things. There is one question I've not covered because it's a pretty tricky and complex question. If time permits, we will, come to that at the end. That was the question of counting matchstick squares, and sort of an algebra kind of question. So I'm going to take about 15 minutes, 10 to 15 minutes to wrap this all together. I know there are teachers, parents here, even for students. I'm going to do a somewhat meta thing. So I'm going to give you some tips. And there are 8 points actually on how to become a conceptual learner, how to build those muscles, right? So the first point is ask actively. So what is this chart here? So there are 3 skills. Question asking is the yellow line, reading is the red line, writing is this sort of bluish kind of line. And x-axis is the age, age 2, age 4, age 6, age 8. So the 4-year-old asks the maximum number of questions. Siddharth has a 4-year-old, so I think he very much knows that. Now, unfortunately, reading and writing as you grow older, till age 10, 12, you keep increasing the use of the skill. But questioning keeps going down. That's what the survey says, which is a big shame, because important discoveries happen only with questions. Deeper understanding happens only with questions. So for some reason, maybe the culture doesn't permit it, maybe you are in too much of a hurry to crack the exam. So there is no such thing as a stupid question. You must ask questions, but the intent must be sincere. The question is not to appear smarter than the other, to sort of, avoid doing your work and say, why should I do this, or things like this. Why should I do this? Maybe a good question in certain contexts. Nothing wrong with that. What, why, how, who, what could be their motive? The questions may need to be different depending on the domain you're studying. I already told you that the more you understand, the more questions you have. So if I had to say only one thing in this entire presentation, it would be ask questions. So if you forget all the other 7 points which are coming, this is the most important thing to ask. You must know whether you've understood something or not understood something. And when you feel you've not understood, you must ask the question. Sometimes you don't know whom to ask. We'll talk about that, right? One second. The second thing is connect concepts. So when things are not connected to each other, it's harder to remember. It's not gotten deep into us. So ask questions. How is this related to that? How is this different from that? So did we relate two different subjects just a few minutes ago? Can anyone, raise their hand or unmute themselves and share some connections we made in the last few minutes across two subjects? You may love one subject and not like the other one also.
Feel free to raise your hand.
Yeah, Ishan.
You can unmute Ishan and answer.
Go ahead and ask Ishan.
No, it was my mistake. Sorry.
Okay. Yeah. So, anybody else? Okay. I think we probably made a bunch of connections, but one thing which Dhruv, please go ahead.
Sir, when we were talking about phytoplankton, then it was biology because we were talking if it was like if about it dying and about what its characteristics are and facts about it. But then when we started to talk about whether it would float or it would sink when it would die, then that was physics also. So we interrelated them so that we could get a
Excellent.
new fact about it.
Excellent. That's a great answer, Dhruv. So the connection between density, buoyancy, floating, and if you go deeper, these phytoplankton can also control at what depth they can, be floating. And if you go deeper into this, we could start. What are phytoplankton? They have, they are. I mean, so I'm scared to say anything because Siddharth, the biologist, is here. But basically, they have chlorophyll pigments. They can photosynthesize. For that, they need light. They need sunlight. Therefore, they have to be within a few feet of the surface of the oceans where sunlight comes in. So it's beautiful. So I used to dislike biology when I was in school, but now I love biology. I want to learn biology again because now I realize everything is interconnected. And somehow that time, I was worried about cracking exams, or there was no time, or internet was not there, so I couldn't do all these things. But hopefully, after retirement, I'll learn all these things. Yeah. So okay. Draw concepts maps as you learn. You can look at concept maps, which is good, but if you can draw them, it's even better. And it helps you, people say visual learner and this learner and that learner. I'm not sure I'm convinced, but I'm convinced that all of us will learn better if we do experiments, if we write about things, if we draw concept maps, if all of us do things through different ways, we will learn better. So all these things are connected, right? That heat is a form of energy, can cause state change, it can cause a change in material properties. So when you draw and put this up and, so apart from your, Taylor Swift or whatever, poster, maybe you can have some of these posters also on your wall. Yeah. So let me go on to the next point. Conduct physical actual experiments when possible. We had an example of that right now. I want you to do the ice and water experiment and write to us. Siddharth will share an email ID with you. An experiment aims to answer a question. It's not just a demo or a recipe. One of the problem, at least when I was in school, and I suspect even now, most of the experiments are already told to you. You do this, you get this reading, right? That's not really an experiment. That's also useful in some ways. But what is far more useful is to answer a question which you don't know the answer to. Like we didn't know the answer to the ice and water when it melts, what happens. But we didn't do the experiment, right? When we can't do the physical experiment, virtual experiments are good too. I shared the PHET Colorado thing. I'll share some other things with you. And if you conduct experiments, you develop the skill of research. We could conduct like a 4 or 5 hour session on each of these things. So, if you want, let us know and we will, conduct some of these sessions. So that's the third thing. There are many, many great resources that help you visualize things, conduct simulations, see patterns. You must use resources, good resources. We will create a resources page on Gifted World and share. But write to us. If you're in grade 7, you're struggling with something, like somebody wrote to us that they're struggling with, say, calculus. So we told them about this book written in 1930s, Calculus Made Easy, Sylvanus P. Thompson. Now, some student in grade 11 has written to us about struggling with permutations and combinations. So we are suggesting a resource there. So write to us. There are a lot of good resources. We will share this with you. You can check it out. I'm going to share one of the CT STEM thing which I have here with me. CT STEM is a great website, CT-STEM. It's a Northwestern University thing. We had conducted a course some years ago. Okay, why is it not showing me this thing? Okay, I think it's logged me out because it has some security kind of stuff. Okay. So I can log in as a student or a teacher. So, for example, ideal gas law. So very well constructed things. So, like you learn the pressure laws maybe in grade 8 or 9, PV equal to nRT, pressure temperature relationships. These are, if you want to understand it really well, you need to understand molecules, temperature, how they bounce, and so then you don't need to mug up many things. You can, so there are questions like, if you cook on the top of a mountain, how long does it take to cook? Will it take longer or this thing? I used to mug it up. But I realized later, a few years later, when I understood the concept that it didn't need to mug it up. So there are these great resources like this. So we share some of these resources in our master classes, or if you write to us on the Gifted World ID, we will let you know what kind of resources to use for things. So I'll go back to my presentation. GeoGebra, Desmos are great tools to do things in math. Ncase.me is a wonderful website. There is a thing called evolution of trust. Just do a Google search on evolution of trust. And there's a wonderful game you can play. It's a game theory thing about, whether you should collaborate with someone or you should cheat them or what you should do. And it's a very, very interesting simulation. So use technology tools to really take things to the next level. Yeah, I already told you about rich resources, fantastic books, websites, YouTube videos. I shared some of these things with you, Calculus Made Easy. All these things will share with you. I don't know how many of you have seen the cartoon guide series. Fantastic stuff. Even master's level students can sometimes learn things from it. 3 Blue, 1 Brown is a great YouTube channel for math. So there's a lot of stuff. Many of you may be already on this Kurzagast thing. So maybe if some of you are really into internet resources, why don't you volunteer? We'll get some of you to conduct a master class along with one of our mentors on different things. All of this is good, but very, very important are master mentors. They could be teachers in your school who have expertise in a certain field. They could be GenWise mentors. I belong to an organization called GenWise. Um, because it's quite easy to get misled to not learn the big ideas, because not all knowledge is just out there in the book and this thing. So they are able to show you what are the big ideas, what are the methods of that field, how do mathematicians work, how do writers work, how do scientists work, right? They're able to inspire you. Well, where do you find them? Join Gifted World. I think because you joined Gifted World, you are here. You can attend the Connecting the Dots series. So finding a mentor and finding peers, it's much more fun to do things together, right? For a lot of us to come together, have a discussion. Otherwise, whom do you ask these questions? Whom do you, do these experiments with? It's a lot of. So find fellowship, find a community, join a club at school or form one. If you want to join, if you want to form a club on Gifted World, let us know. It'll be a lot of work, but maybe we can work with you to, help you form that club. We are very young, but we plan a lot of things. We already have 4,500 members and a lot of very curious kids out there. Join Gifted World masterclasses, online workshops, go to a summer camp, come to our summer camp or some other summer camp. So 3 weeks of, aero modeling or neuroscience, or making a Rube Goldberg machine. So being with other kids who are interested in this, no exams, no tests, it's a great way to really sort of have a transformative experience. The last point, it's already 6:40, so I'm going to make this last point, sum it all up and hand it over to Siddharth. I don't think I will do that tough question. If some of you are interested, we'll talk about that later. So practice persistently. There is no substitute for hard work and practice, but you need the right kind of practice, right? So you have to catch a good teacher, or there are good books where if you do all the sums in the back of it, it's worth doing all of those things. Because you internalize things only when you do like 100, 200 sums, and good teachers will make good worksheets where, the sums will be different. It doesn't mean that if you solve the first three, you can solve all the other, right? They would have given a small twist and so on. So you need to do all of these things. And I sometimes come across children, they say, I've understood this. Why do I need to do this? And then, they face challenges later. So it's not enough that if you just understand things once, you need a lot of practice to internalize things. So there's a great cartoon which I stole from the internet. So challenge accepted, then this is harder than I thought. I don't get it. So there will be a time for which you will despair. And then, it comes out. I'm going to talk very, very briefly about this question. I won't get into details and you may struggle with this because very, very few of you have attempted this, right? So this question was really about, we are making squares from matchsticks. How do we count and, in the nth square, how do we come with a formula for that? And it's not difficult actually. So this method is quite easy. So if you take, the red vertical lines and the blue horizontal lines, I'm going to send you this presentation. You can easily find out that, okay, there are n rows of n+1 matchsticks, n columns of n+1. So 2n into n+1, you get the answer. I'm going very fast right now, but if you spend 4 or 5 minutes on it, you will get it. But the trickier question I had asked was a different way of counting. So I actually made this mistake, by the way. So this was there in a teacher training course, and one of our mentors, Jayashree, was teaching it. And this is me, Vishnu, actually making this very, very stupid mistake. So I made this mistake where, so I took, say, n is 3 here. So, okay, I don't want to, this will get confusing, but basically I made a very stupid mistake. Because if n is 3 here and I want to divide that. Like, so in this method of counting, what we are saying is you take this blue rectangle on top, the blue rectangle at the bottom, and then you take all these red marked matchsticks here. So using this pattern that, this again has blue rectangles, red matchsticks, can I predict for the nth thing? So what I had to do was I had to take this n thing and divide. Okay, I knew that there are two blue rectangles and one row of red things. So 2 and 1. So I did something very stupid. So I said, okay, 2. 2 is 3 minus 1, I said. And 1 is, 3 minus 2. But this is completely wrong because n minus 1 plus n minus 2 should give me this whole number, n minus 3. So it just worked accidentally for 3. I'm going very fast. I'll send you a note on this. So, but I'm very glad, and Sparsh Mondal is here, and Sparsh Mondal has given a fantastic answer. So I was wrong completely. But Spandan, not Spandan Mondal or Sparsh Mondal, I don't know, one of them. One is the child and one is the father, I guess. Gave a very good answer. So I noticed that whether it was teachers or adults, parents or students, almost nobody attempted this. Very, very few attempted this because this is a hard question. And this is the reason I also got it wrong. So what had happened to me was I did this in a hurry. I got the wrong answer. I said something is not working out. The next day I sat patiently. I worked it out over 15 minutes. I got it right. Because the first day I realized that for odd and even it will be different. Then I said, oh my God, for odd I have to do this, even I have to do this. I don't want to do this right now. I will try some shortcut. So Spandan, Spandan, you want to talk about this?
I just wanted to let you know that I'm here.
Spandan, you'll have to increase your volume. Yeah.
So can you hear me now?
Yeah, go on.
Sir, I just wanted to let you know that I'm here. I'm present.
Okay, good. So Spandan, excellent answer. I really loved the way you explained it. Good work. Spandan is from the Newtown School in Newtown, Kolkata. So Spandan did not do the final simplification, but he did everything correctly. So I wanted to just very quickly share this example because there is a tendency to avoid hard and difficult work. Right? I avoided it. Then, when I got it wrong, then I had to sit and do it. So do not avoid hard and difficult work, especially if you think you like the subject, you want to pursue that subject, or it is important for some reason towards your goals. So practice persistently is very important. So Siddharth, I'll wrap up in 2-3 minutes, and then we can go into the wrap up. Okay.
We still have 13 minutes. So
Oh, great. We still have 13 minutes. So I'll maybe take 4-5 minutes then. So look at this. Suddenly so I'm being a little bit strict out here. So for almost everyone attempted the first few. Matchstick squares only 7 attempted, right? I'm sure you were very busy and you're doing other things. But where it got difficult, people became a little lazy. And only Spandan answered it correctly. There were a couple of people who came a little bit close to it, but they did not give the answer in a painstaking way. So maybe they had got the correct answer, but they couldn't express it perfectly. So okay, I'm going to give you an acronym to help you remember these 8 points more easily. So before I give you the acronym is craft map. So learning is a skill. Craft is another word for skill. So as you do these kind of things, asking questions, active experimentation, playing around with the simulation, persisting with the thing, asking the doubt, finding a mentor. As you do these things, you will develop the skill. But learning is also a journey. Like I said, it's not linear. You'll have challenges, you'll come back. So journeys need maps. So remember craft map. I will tell you how it expands. So C is for connect concepts, R is for rich resources, A is for ask actively, F is for find fellowship, T is for technology tools, M is for master mentors, A is for active experimentation, P is for practice persistently. So that's pretty much it. So I'm going to stop now because I've spoken a lot, and so we can have a 5-minute Q&A, I think, right? So maybe something is there in chat, or someone wants to make a comment or ask a question.
Yeah, so far there haven't been any questions in the chat,
Okay, okay.
but
So I can stop my screen share, right, Siddharth? Yeah.
anyone has questions, feel free to raise your hand so that we can call on you.
Or you want to just say something, how your experience was answering these questions, or, today's session. So Ilham Stali, is this a student or a parent, or would you like to?
Think a teacher.
A teacher.
Mitanshi
Right.
raised her hand.
Right. So I just want to make a comment on this, that nothing against knowledge. And in fact, concepts is part of knowledge. The thing is, when the knowledge is not connected, that is when it is an issue and you can't, really use it. And sometimes you have to change that knowledge. So even doctors, sometimes, they have to change that knowledge, and sometimes the thing. But yes, nothing against knowledge, absolutely. So all critical thinking happens in the context of what you know. Just because you are a great surgeon doesn't mean you can be an air traffic controller. Just because you're a great air traffic controller doesn't mean you can be a great mathematician. So knowledge is very important, nothing to run down knowledge. Yeah, Mitanshi, please go ahead and say what you want to say.
Couldn't understand the matchstick question.
Yeah. So Mitanshi, we don't have time here to get into the matchstick question, but
So I
we
didn't
can.
understand the formula.
Yeah, which grade are you in, Mitanshi? Fourth. Yeah, Mitanshi, what we'll do is we'll send you something to do, and we have this connecting the dots in maths course for grade 4 and 5 students also in January. Please join that if you can, and we will, because here to get into that itself and do it properly will take 15-20 minutes. So I'm sorry, in this session we can't cover it.
Okay, sir.
Yeah.
Thank you.
Thank you.
Bye, sir.
Viraj
has a question.
Yeah. Viraj is asking.
Life without mugging things up? If yes, then how?
Viraj, that's a great question. It's good to refrain from mugging up things because many things which people mug up actually don't need to be mugged up, and you can just do it. But there are sometimes there are situations where mugging up is needed, right? Okay, so let me say a couple of things about that. So some things have to be in your memory. Immediately you have to remember. Now that may not happen because of mugging up. It may just happen because you keep looking at the thing again and again. So it's not just mugging up. That is one clarification. But sometimes mugging up is an easy way of remembering things. For example, I mugged up the multiplication tables. It's very useful for me now. Many of you have mugged up multiplication tables. The reason it is important sometimes is because you need to do a lot more things with it. You cannot be waiting to think, is this a multiple of 2? Is this even? Is this a multiple of 4? And things like that. You cannot be waiting to think because more advanced things depend on that. Sometimes you need, so for example, the activity series in chemistry, I don't know which grade you are in, but sometimes you need to know which element will displace some other metal. So you may need a mnemonic. You may need to mug up that, something like even craft map, what I just shared now, it could be mugging up. So don't be against mugging up. It's a good attitude to say that, why should I mug this up? So if you're not convinced that, mugging up is going to help in any way, don't mug up. But sometimes you may just need to mug up a few things. I'm seeing some other questions, Siddharth, so I'll take a quick look and see. How can we understand the question in the paper? Because we can't do experiment there, because the question will be, you mean when you're taking an exam? When you're taking an exam, you can't do experiments. So all these experiments are when you are learning at home or in school. Recording later, I'm not sure if we can share. Maybe if you've already registered for this session, maybe we can make it available for a couple of days. Buoyancy testing, the steel beams are also using air. Yeah, that's right. So the thing is, nobody tells you generally that you have to take the average density. Ishan caught on to it very nicely. So there is air also in it. There is the human body. If you go into the pool, if you don't drink water, you're going to float. Why do you float? Even though your bones are much more dense than water. Because there is a lot of air in your lungs, there is air in your body. So yeah, the average density of the human body will turn out to be very close to water. You can do the calculations. I'm running a quiz club in my school and sometimes I struggle what to choose, questions and challenges. Yeah, Ilham, write to us. We'll share some ideas and maybe, yeah, Bertie, Ashley, Siddharth is sharing something. Siddharth, maybe we can have students work with us to do quizzes on Gifted World. They can, maybe we can help them with the school quiz also. We can collaborate with them. Yeah. Devik shared a very interesting thing. When your lungs are filled with air, it makes average density of body lesser than that of water. Okay, great. So Siddharth, I think if there are no other burning questions, you should do the wrap up and
Sure.
go ahead. Yeah.
Yeah. So hold on, let me just remove the spotlight. Okay, great. Now we can see everyone again. So thank you all for coming today. I hope this was an enjoyable session. The quiz certainly was a lot of fun. When I shared it out, I think my school biology teacher, right? I was last in school 16 years ago. She also was very interested and filled it out. Right. So the reason I wanted to share that is if you're really committed to learning, it never stops. Right. It's something you can go on doing and you can go on enjoying it. Another thing I just wanted to share about the point for mugging it, my good friend all through college and we both were very, very keen biologists. We learned a lot of biology, but still in 10th standard, I got my friends to draw all the images in my biology record because I couldn't draw. Okay. But my good friend and I were joking when we finished our masters that we've forgotten more biology than most like students learn in their undergrad. We've forgotten more biology than most students learn in their undergrad. And that's important because if you learn something once, it's okay if you forget it. You remember the structure of it. You remember the connections of it. Then when you need to find that again, it's very quick to find it. That is something that generative AI cannot do for you, which is make the connections in your own head. So don't be scared about having to memorize things. You memorize it today, you forget it tomorrow, but somewhere you remember the structure of it. And that's helpful. So anyway, with that, please we will send an email to all of you with the slides from today's session. We'll send a PDF of the slides so that you can access them. As Vishnu said, we'll also keep a recording accessible for a few days for those of you who weren't able to attend the session or weren't able to catch the whole session. Okay. And please do connect with us on Gifted World. The quiz that Vishnu shared is available as a challenge on our blog. In case you haven't done it, you can try it out. We'd still love to get your answers, and we keep putting up challenges like that around twice a month is what we try to do. And we're very excited for the Connecting the Dots courses that are coming up, because the people teaching them are people who have really a lot of experience and are, as I said, these curious learners who never stop learning. Okay. So full disclosure, I'm also teaching two of the courses. I'm complimenting myself over here. So thank you all for joining today, and I wish you all a great weekend.
Thank you all. Have a great weekend. See you. Bye-bye.
Yes, we can all unmute and say bye.
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 Thank you, sir.
Bye-bye.
So,
Bye.
Bye.
thank
Bye.
you.
Bye.
Bye, sir. Thank you.
Bye, sir. Thank you.
Bye bye.
Bye, sir. Thank
Bye, sir.
Bye-bye. Which grade are you in, Jashan and Harshit?
Sir, 8th class.
8th
Shri
class.
Rama Bharati Public School, Patel Nagar.
Okay. Okay. Thanks for coming. Hopefully you'll understand something next time. Yeah. Okay. Yeah. So Siddharth, okay.
And let me stop the recording.
Yeah. Hi, Sumit. You are still around? Acha.